For number 46, the oral questions, we're asked to identify what transformation is used to take this initial equation and transform it into this new equivalent equation. On the left side, the 3ay has turned into 6ay. On the right side, 27a has turned into 54a. The transformation is to multiply both sides by 2. For number 3, how do you change the initial equation into this new equivalent equation? The left side still has the 3ay term, but notice a plus 3a is now next to it. On the right side, 27a plus 3a makes the 30a. So the transformation is to add 3a to both sides of the equation. For number 13, we're asked a true or false question. Is a equal to d plus e plus b? And what we have to work with is this given information. A plus b is equal to c, and c is equal to d plus e. Let's make some transformations of this equation to see if we can show that the left side is equal to the right side. If so, we're going to answer true. One of our given facts is that c is equal to d plus e. So this portion of the equation can be replaced with the variable c, and that's called substitution. So let's transform our equation into this equivalent form. Next, let's subtract b from both sides of the equation. The left side becomes a subtract b, and the right side just becomes the letter c once you subtract the b away. At this point, we can see that this equation is false because it contradicts one of our given statements, that a add b is equal to c, not that a subtract b is equal to c. Let's try number 15 in a similar fashion, possibly making substitutions, but also using the transformations to equations, like adding the same thing to both sides or subtracting the same thing from both sides. We want to figure out if we can show that the left side is equal to the right side. In place of a plus b, we could substitute c because of this first given fact that a plus b is equal to c. That allows us to transform into c equals 2c minus b minus a. Next, let's subtract c from both sides. When you subtract c from the left side, you end up getting 0. And on the right side, now there will be 1c. And there's still the minus b and the minus a. Next, let's add a and add b to both sides of the equation. The left side will become a plus b, and the right side will become c. The reason I added a and added b was to eliminate the negative b and the negative a from the right side of the equation. At this point, we can tell that this is a true equation because it matches that first statement that was given to us. Next, we have page 47, some written exercises. We're asked to solve the equations and then check our answer using substitution. We solve equations using transformations, like adding to both sides or subtracting to both sides. On this first one, let's subtract 3 from both sides of the equation. That will leave the 2x on the left side because the 3 is subtracted away. And on the right side, we get 6. Now we can see that the answer is x equals 3 because 2 times 3 is equal to 6. We're asked to check that answer using substitution. So replace the x with the number that we think is correct. And what we're wondering is, does that equal 9? 2 times 3 is 6, and 6 plus 3 does equal 9. This answer checks. Number 3, first let's combine like terms. 5m plus 4m is 9m. Next, subtract the 72. We have 9m on the left side, and on the right side, after subtracting 72, we'll have negative 72. And next step, divide both sides by 9. 9m divided by 9 makes m. And negative 72 divided by 9 is negative 8. We think the answer is negative 8. Let's do a check. Take the original equation, and where the letter m is, fill in negative 8. We're wondering, does that equal 0? 5 times negative 8 is negative 40. 4 times negative 8 is negative 32. Negative 40 subtract 32 is negative 72. And negative 72 add 72 does make 0. This checks. Number 5, we could subtract 4x from both sides. 6x subtract 4x is 2x. On the right side of the equation, after subtracting the 4x, we have negative 2 left. Now we could subtract 4 from both sides. We get 2x equals negative 6. Therefore, x is negative 3, because 2 times negative 3 equals negative 6. Let's check if that's right. Replace the variable x with the answer that we think is the answer for x. On the right side, the same thing. Replace the x with the number that we think is the answer. Now let's see if the left side expression does equal the right side. 6 times negative 3 is negative 18. Negative 18 add 4 is negative 14. On the right side, 4 times negative 3 is negative 12. And negative 12 subtract 2 is negative 14. This answer checks. Now number 7. Let's subtract 5x from both sides. 3x subtract 5x is negative 2x. On the right side, after subtracting 5x, we only have the 8 remaining. Now let's subtract the 16. We have negative 2x equals, and 8 subtract 16 is negative 8. Now divide by negative 2. So we get x equals 4. Let's check to see if that's correct. Fill in 4 for x. On the left side, 3 times 4 is 12, and 12 plus 16 is 28. On the right side, 5 times 4 is 20, and 20 plus 8 is 28. The answer checks. Now number 9. Let's solve the equation for x. Our first transformation step could be to multiply both sides by 7. When you multiply the left side by 7, your denominator cancels away, leaving 3x. On the right side, 21 times 7 is 147. Now divide by 3. We get x equals 49. Let's check if that's correct. 3 parenthesis 49 divided by 7. Is that equal to 21? When simplifying this expression, it would be easier to divide the 49 by 7 first and then multiply by the 3. 49 divided by 7 makes 7, and 3 times 7 is 21. This answer checks. For number 19, we're given an equation that has several variables in it. And we're given values of all of the variables except for one. In number 19, we're asked to solve for the lowercase b. So let's substitute for every other letter. For the p, fill in 50. The lowercase b is the one that we don't know, so we leave it as a variable. For capital B, fill in 11. And for the s, fill in 10. Let's solve this equation. On the right side of the equation, we can simplify all of the constants up to a single number. So 50 equals b plus. 2 times 10 is 20, and 11 plus 20 is 31. Now we can subtract 31 from both sides. 50 subtract 31 is 19, which is equal to b. Because of the symmetric property, this could be rewritten as b equals 19. We have the answer. For number 23, let's solve for lowercase h. The capital L gets replaced with 12 pi, and the lowercase r gets replaced with 1.5. And then here's the h. We can simplify the right side a little bit by multiplying the 2 and the 1.5. So our equation is rewritten as 12 pi equals 3 pi times h, because 2 times 1.5 is 3. To solve for h, we need to divide by the coefficient 3 pi. Dividing is the opposite operation of multiplying the h by 3 pi. So our transformation is dividing by 3 pi. 12 pi divided by 3 pi is 4. And on the right side, when you divide by 3 pi, the letter h is now alone. If you don't believe that 12 pi divided by 3 pi makes 4, then over here in the margin, let's show that out. 12 pi over 3 pi. The pi over pi cancels away, and the 12 over 3 makes the 4. For number 25, we have our equation written in set notation, and we're asked to solve for z. But this is really the same skill as what we were just doing. So don't let the set notation bother you. Focus on the equation and solve it for z. On the left side, it looks like we can do a little bit of combining. 7z subtract 1z is 6z. Then let's focus on the constant term. We're subtracting a 2, so we write minus 2. On the right side, we can do distributive property. 2 times 3z is 6z, and 2 times negative 1 is negative 2. At this point, notice that the left side expression is identical to the right side expression. Whenever that happens in algebra class, any number that you choose to substitute in for z will make a true equation. So the answer for z is all real numbers. If you don't believe that, try a few. For example, what happens if z was 1? 6 times 1 is 6, and 6 take away 2 is 4. And on the right side, when z is 1, you also get 4. Or what happens if z is 0? 6 times 0 is 0, and 0 minus 2 makes negative 2. But on the right side, you would get negative 2. Any number you substitute in for z will create the same value on the left side as on the right side, because these are identical expressions. Therefore, the answer is all real numbers. Number 27, solve the equation for x. It looks like on the left side, there is some distributive property that can be done. So we have 13x minus 6x minus 18. On the right side, how about combining like terms? 7x. Now let's combine like terms again. 13x subtract 6x is 7x. At this point, notice that both sides of the equation have the expression 7x, but the left side is 7x minus 18. From here, we can conclude that the answer is empty set. There is no number that you could put in for x and ever make this expression turn out to be equal to this expression, because the one on the left is always 18 less than whatever the one on the right turns out to be. Number 41, solve this for h if we're given these values to substitute. So capital V, fill in 48 pi. And for r, fill in 3. Next, we can do some simplifying. On the right side, 3 squared makes 9, but then 1/3 times 9 is 3. Now let's divide both sides by 3 pi in order to isolate the h. 48 pi divided by 3 pi makes 16. For the review assignment, we're on page 43. Simplify this expression. So it's no longer an equation. We can do some distributive property. So start with the 5 and now distribute the negative 2. Negative 2 times 3r is negative 6r. Negative 2 times positive 4 is negative 8. Now we can combine like terms. Negative 6r plus 1r makes negative 5r. And 5 subtract 8 makes negative 3. Number 13 has some distributive property. Here, and then here in the middle. 30 times x is 30x. 30 times negative y is negative 30y. Negative 8 times x is negative 8x. Negative 8 times negative y is positive 8y. Then on the end there's the plus 10xy. Now let's combine like terms, beginning with these x terms. 30x subtract 8x is 22x. Now the y terms, negative 30y plus 8y. That's negative 22y. And then we have our positive 10xy term. Number 21 has some distributive property. So let's begin by multiplying here and multiplying here. The expression starts with 5t and then plus 3s, now the distributive property. Negative 2 times 2t is negative 4t. Negative 2 times negative 4s is positive 8s. 3 times 5s is positive 15s. And 3 times 8t is positive 24t. Now look for like terms, perhaps starting with the letter s. We have 3s plus 8s, which is 11s, plus 15s, which makes 26s. Now the letter t, 5t minus 4t makes 1t, and then add 24t makes 25t. Before going to the next problem, let's take one last look to make sure that we have gotten every term and haven't skipped any. For number 33, it's another one of them where you solve for one of the variables because you've been given values of the other variables. This time we're asked to solve for capital R. So for the K, fill in 9. For the L, 100. In the denominator, for the letter D, fill in 5. Now let's simplify this expression. We have 9 times 100 divided by 25. We could multiply 9 times 100 first and then divide, but that makes quite a large number to divide by 25. Let's first divide the 100 by the 25, which makes 4. And then 9 times 4 is 36.